Welcome back to my YouTube channel in this C programming series. Okay, today we're going to talk more about variables. We're going to talk about math, um, uh, arithmetic functions. So let's just get into it. Let's take out this statement right here. So you could do various math. Like you could say 5 plus 5, 10 plus 10, whatever. But you'd want to stick that in a variable. Like if I were to do int a equals 5 plus 5, that would be assigning the result of 5 plus 5 to a, which would be 10. Um, you can even print out stuff. So let's just say here 5 plus 5, just print out the numbers themselves, equals some integer. Remember, %d is the format specifier for an integer. And then put \n for new line. I'm going to put here 5 plus 5 like that. And you get the result of 5 plus 5. Let's build and run that. Just got to build. There we go. 5 plus 5 equals 10. Now, what would happen if I were to say, if I were to say %u, which is for unsigned int, well, that's still going to be the same thing because 10 can be represented just as easily by an int or an unsigned int. But what if I were to do something like negative, or 5 minus 10? That's going to be negative 5. And if I were to represent that as just a %d as a regular integer, it will show negative 5. But if I were to represent that as %u as an unsigned int, well, that shows some big number because it's like it wraps around, and unsigned int cannot hold, the %u is for unsigned int, and that cannot hold the negative number. So it will make the first bit as a 1 to make it negative. It wraps around, uses something called 2's complement, but don't worry about that too much. Maybe sometime in the future we can talk about 2's complement and maybe 1's complement. I mean, you could do many things. What if you were to make this like a C? Then it's going to be like a character, which is going to be funny. It's going to be some big character here. If you make this, let's just say 65, which is the value of A, plus 5, so that'll get you the 6th letter. And it'll get you an F, a capital F, there, right there. %C, but if we represent it as an integer, it'll be like that. It'll be the number 70. And what if we were to say represent this as a float? So %f for float. It's going to add some decimals after it because it's a float now. By the way, if you want to say this number is a float, so the compiler knows to represent it as a float, you can do 5.f or 5.0f. Either way, it'll still be a 10. And if you want to represent it as a long, it would just be like 5.0 and something like that. 5 point, either way, either of these will work. We could put LF for long, that mathematical expression. So, I mean, LF for the long format specifier, I'm sorry. You can, let's just say, you make a number here. So you make int A, and you can even make short B. Just remember the range of short is only the 65 or 32,000, where int A can go to 4 billion, usually, assuming the most common lengths of these sizes of these variables. But anyways, you can do, let's just say you can assign them values right away, or you can do it later. So let's say one we do right away and another we do later, just to show. And then we do A plus S, Well, actually, let's put it down here into the printf statement. So we can do like a plus s like that, you know, and just make this integer, and that'll be 5 plus 3. So that'll be an 8. There we. Oh wait, let me change this to be 5 plus 3 here so that it shows us that. But to actually make this so like if I change this now to 7, this is not going to say, this is still going to say 5 plus 3, right? So 5 plus 3 equals 12. So what we should do is we could put here a plus s, or actually percent d plus percent d, and then over here put, so first a corresponds with the first percent d, and then s the second percent d, and then a plus s. And if we do it like that, then we get the correct things. 5 plus 7 equals 12. And now if we were to change 7, to like 10, it will stay correct. It'll be 5 plus 10 equals 15. Or let's like change a now to 30. So now we've updated a to 30, and we'll say 30 plus 10 equals 40. So it'll, the way we have it now will update correctly. And you can like use floats and put floats in there and put percent %f for float. In the float specifier, you can put L percent %LF for long float, percent U for longs, or percent UL for unsigned long. You can do all that stuff. You can even like say like, hey, make a new variable. It could be whatever. Make an integer or a long. Just put b here equals a plus s, and then down here we could change a plus s to b, and then just show that 10 plus 30 equals 40, or 30 plus 10 equals 40. But now if we were to change a here to 50, b is not going to change just because you changed a, because b was set before you updated it. So now this reads wrong. So you got to be mindful of that kind of thing. Now if we were to say here, now set again b equals a to s, it will be correct. See, now we have 50 plus 10 equals 60, because we've signed it now again after we've updated a. So that's something to be mindful of. And b could be a long or unsigned long. Just make sure that the resulting variable can hold all the variables that go into it, like for the calculation. Otherwise you're gonna run into some logical errors, some bugs sometimes. So if I were to have like short, or s is already short, so if I were to say a is equal to 100,000, and then I said s equals a, it's not gonna be what you expect. Or actually, you know what? I think the compiler is doing some tricks. Oh no, it's because I've got 10,000. Sorry, and then a equals 100,000. Yeah, see now, like even like s here is 31,000, negative 31,072. It's because you've put it into something that cannot contain that value, so it does what's called a wraparound. Now, if I were to do a plus b, it's going to be it's not going to be, s is not going to be 10,000, and what I put here, like it's not going to be 10,010 in this case. It's this. So be mindful of that. And you can even like compare values. Like if I put here a equals 30, I can actually say here, if a equals 30, print f, yay, a is 30. I can do this. And, if I can then say here, else, you know, printf, A is not 30. Sad face. Like that, I'm getting a little bit into if statements now, which I wasn't planning for this lesson, but yeah, yay, A is 30. And then here, put a new line here, and then, or actually, you know what? We can even put it just at a new line here, and yeah. Now these numbers are completely wrong. Ignore that. I'm gonna comment that out to ignore to whatever. Now, if I put these backslashes here, that's what's called a comment. So you can use that to say like, this code does something by whatever. It's like a note to whoever's going to read this code, but the program does not run it. Or I can comment out multiple lines by putting a backslash, a slash star and a backslash star. And you see it turns gray here, So I've commented out all that too. So now there's nothing printing out except this other stuff. I don't think you can't really nest comments, because if I put this, like, this thing now is not commented out anymore. So, but now get rid of this. And so comments are good for leaving notes with the users. They're also good for sort of like, if you're ready, if you want to get rid of some code, but you're not quite ready to delete it completely, you can use them. Now let's print this out. A is 30. Now what if I were to make A not 30? Make it 31, for example. A is not 30. It doesn't say go to if A is 30, it goes to here, right? And we can say like, if A is less than 40, printf A is less than 40. Otherwise, we can say like printf A is not less than 40. So right now it'll be less than 40 because A is equal to 31. So it'll do this line. And is there an error here? Hold on. Oh, forgot a semicolon. Yeah, you got to put a semicolon at the end of each line, except for lines that end in curly braces. Basically. Okay. Yeah, so now we have A is less than 40. A is not 30. Now let's put like a new line in between here. Just put a backslash n for new line. Yeah, so now it's on another line. A is less than 40. A is not 30. What if we were to make A 40? Well, then it's going to be equal to 40. So then it's going to do the second part. So A is not less than 40. A is not 30. So A is equal to 40. Is A less than 40? Well, 40 is not less than 40. So it doesn't do this line. So then else, then it does this line. So, you can do like these like kind of like conditions and stuff. I wasn't planning to do if statements for this lesson, but, I guess I kind of got into it. And also if we go more than 40, it's also going to run the second line because 41 is also not less than 40. So actually, let's recompile and run that. A is not less than 40. So here we have A is equal to 40. So then assigning it to A equals 41 to A, sorry, not 40. And then it checks if A is less than 40, which is not true. So then it goes down to here. So else, so it does this other thing, else, not if this, but else this. It does print if A is not less than 40. Okay, yeah. So you could kind of do this thing where you have math and you could do like comparisons and so forth once you assign variable stuff and like print out the values of like math, the results of mathematical operations directly or from variables or whatever. You got to be careful about assigning, the results of variables that contain a wider range, or like then into a variable that contains shorter range. Otherwise, you're going to get like a bug where you're not going to have expected values in there and so forth. Yeah. And so I think that's good for now. Not sure what we're going to do next lesson. Maybe we'll get more into if statements or something like that. But yeah, so um, to keep getting these C programming lessons, subscribe to this channel and leave a like. That would really help out. And comment as well if you like. And you can also check out my Twitch channel, Cool Coding Cat, and also there's a channel, Cool Coding Cat. All right, so peace out.